Hey y'all, in this lesson, I'm going to teach you about the double angle identities in trig. Here I have listed the identities that we're going to be using today. If you've got your sheet of paper or your note cards, you might want to write these down or highlight these because you will definitely be seeing them. So we have sine, cosine, and tangent. So just, take a mental picture, write those down real quick, and we're going to use those to solve this problem down here in the first example. It says if sine x is 4/5 and x is in quadrant 2, that matters because of the sign of the answer. Find the exact values of cosine 2x, sine 2x, and tangent 2x. Before we can get into the double angle formulas that we're looking for, we need to first figure out what cosine and tangent are. We were given sine x, and we were given the fact that it was in quadrant 2. So I'm going to draw a picture here. Quadrant 2 is over here. And I've got this triangle. And this is going to be theta. Sine is opposite over hypotenuse. So this is going to be 4. This is going to be 5. You can use the Pythagorean theorem to figure out the other side, but this is a common triangle. This is a 3, 4, 5. But it's in quadrant 2, so 3 is actually negative. That means that cosine x is adjacent over hypotenuse, and tangent x is opposite over adjacent. You could probably write that as -4/3. Put that negative out front instead of in the bottom, makes a little more sense. Now that we know sine, cosine, and tangent, we can apply our double angle identities. So if we're looking for sine 2x, let's go up to sine. Sine 2x is going to be 2 sine x cosine x. I'll go down here, write that out. 2 sine x cosine x. Now it's just a substitution game. Sine x is 4/5 and cosine x is -3/5. I'm going to multiply all of that out. 2 times 4 is 8, times -3 is -24. 5 times 5 is 25. That one was simple enough. Let's now do cosine 2x. Cosine 2x is either, we have lots here, cosine squared a minus or x minus sine squared x, or you can apply the Pythagorean identity and have some different ones. I'm just going to use the original one since I already have cosine and sine. It's fine. It'll work. Cosine squared x minus sine squared x. I want to make sure that I wrote that down correctly before I move on. Yes, I did. And now with substitution, for cosine, I have -3/5. For sine, I have 4/5. Square both of those. You're going to square the numerators and the denominators. And then subtract. I have a common denominator. So if I subtract that, I'm going to get -7/25. And that's it. Now tangent 2x. Let's go up, look at our identity for tangent 2x. We've got 2 tangent x over 1 minus tangent squared x. 2 tangent x over 1 minus tangent squared x. Tangent x was -4/3. So I'm going to substitute that in, 1 minus -4/3 squared. Now multiply out, I get -8/3 over 1 minus +16/9. In the denominator, I'm going to have to do some simplifying. I've got -8/3. That's going to be 9/9 minus 16/9. So that's -7/9. then simplify even more. You can type this in your calculator if you want to. I'm just doing it by hand for the sake of the lesson. Simplify that. We'll get negative 24 over 7. Nope, positive. There's 2 negatives there. Sorry about that. Positive 24 over 7. And that's it for that problem. Whoops, I'm in eraser mode. Here we go. All right, moving on. Find the exact value of cosine squared 15 minus sine squared 15. We don't know cosine 15 or sine 15. So let's reverse engineer this, use your identities, and try to solve this one on your own. Pause it, try it, come back and check. This one is going to be the double angle identity for cosine. It matches up with the cosine identity, so it's going to be cosine 2 times the angle. So 2 times 15 is 30. Cosine of 30 is positive square root 3 over 2, and that's it. Okay, next one, we're going to solve cosine 2x minus 1 equals sine squared x such that x is between 0 and 2 pi. So I'm seeing a sine squared x. I'm going to go ahead and leave that, but I am going to change cosine 2x. You can see where these identities are definitely going to come in handy. Cosine 2x, I did have several identities for that. And I'm kind of hoping I can find one in terms of sine, since I already have that sine squared x on the right side. So if I go up here, I do indeed have one in terms of sine. 1 minus 2 sine squared x. So I'm going to go down here and I'm going to change that to 1 minus 2 sine squared x. And then I have my minus 1 and then equals sine squared x. I'm going to move, I really want 0 on the right side, so I'm going to move sine squared over here. That's going to create that 0 on the right. And then I do have some simplifying. 1 minus 1 is 0. And then negative 2 minus 1 is negative 3 sine squared x. Then we're going to divide both sides, by negative 3. And we get sine squared x equals 0. We can square root both sides. Sine x equals 0. So we're looking for values of x where sine is 0. And that is going to be at, let's see, 0, 2 pi, and pi. 0 and 2 pi are the same. So I'm just going to say 0 and pi. There you go. Now let's solve this next one. We have cosine 2x equals cosine x on the interval of 0 to pi. Pause it, try it, come back and check your work. We've got 2 solutions here since it's between 0 and pi. It's going to be 0 and 2 pi over 3. We don't need to go 4 pi over 3 or 2 pi because that's not in the interval. All right, that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.